Hello, in this video, we are solving one more example based on a circular time shifting property of DFT. Let's start. Example is find DFT of x of n is equal to 1, 2, 3, 4. These are the samples of x of n. And second point is using the result obtained in 1, find DFT of following sequence x3n and x4n. So this is the example. So first we'll find DFT of x of n by direct method by using the definition by matrix method. So this already we have solved in a previous example or previous video. So this is x of k DFT total factor matrix, and this is x of n our input 1 2 3 4. This is total factor matrix value. This is x of n, and do the matrix multiplication to get the DFT. So matrix multiplication, this is the result of matrix multiplication, and this is our DFT x of k 10 minus 2 plus 2j minus 2 minus 2 minus 2j. These are the four samples we are getting for x of k. For detailed explanation of this one, you can refer previous video how to find the DFT of sequence. Now, here we want to find DFT. The second question is using the result obtained in a 1, that is your x of k which we have obtained by matrix method. This result we are using to find the DFT of x3n and x4n. So for that we first need to check the relation between x of n and x3n, because we have the DFT of x of n and we want to find the DFT of x3n. So for that we should know the relation of these two sequences. So x3n is 3, 4, 1, 2 and x of n is 1, 2, 3, 4. If you check, the sample values are same, only in a x3n it is in a shifted manner. So we'll see how much shift is required in a x of n to get x3n. So first we'll add shift by 1 unit. It is delay operation, that's why it is in a anti-clockwise. So x of n minus 1. It 4 will get shifted here and other sample values get shifted by 1 unit right side. So 4 and 1, 2, 3. Then we'll add one more shift. Here we'll check the values of x3n and x of n minus 1 doesn't match. We'll add one more shift. So x of n minus 2 is this 3 will come this side, and then 4, 1, 2, 3. 3, 4, 1, 2. You can check your x of n minus 2, 3, 4, 1, 2 and x3n is also 3, 4, 1, 2. That means x3n we can obtain by applying delay of 2 unit to the x of n. So we can use here time shifting property, circular time shifting property. If x of n is the sequence and if we know its DFT is x of k, then we can easily find the DFT of delayed version of x of n. So x of n minus, here x of n minus 2, L is 2, x of k which we already know get multiplied with the wn lk. Here L is 2 because our x3n is same as x of n minus 2. So L is 2 here. So our x3n is nothing but x of n minus 2. So using circular time shifting property, DFT of x3n is x of k wn L is 2. That's why wn2k. So x3k is equal to x of n get multiplied with wn2k. And what is capital N? There are 4 samples, that's why it is 4-point DFT. So capital N is 4. Let's find x3k is x of k wn2k. 2 is the shift. X of k we already calculated by matrix method. It is 10 minus 2 plus 2j minus 2 minus 2 minus 2j. This result in a first we are using to calculate x3k for the second. So x3k is x of k, wn, n is, capital N is 4, w4 to k, where k varies from 0 to n minus 1, n is 4, so that is 0 to 3. To find the Twiddle factor matrix value, we are using phasor diagram. So k varies from 0. So k is equal to 0 in this equation. x3 of 0 is equal to x of 0 get multiplied with w4 to k is 0. So 2 into 0 is 0. So x of 0 is 10. It will get multiplied with w40. Check w40 is 1. So 10 get multiplied by 1, it becomes 10. That is x3 of 0. Then k is equal to 1. Okay, k is equal to 1. x3 of 1 is equal to x of 1 w4 2 into k is equal to 1. 2 into 1 is 2. So w x of 1 is minus 2 plus 2j and w4 2. w4 2 is what? w4 2 is minus 1. So put it, w4 2 is minus 1. Multiply this value with the minus 1. What will get? Minus 2 minus 1 2. Then minus plus 2j minus 1 minus 2j. Then k is equal to 2. K is equal to 2. x3 2 is equal to x of 2 w4 k is 2. That is 2 into 2. 2 into 2 is 4. So x of 2 is minus 1. Sorry, minus 2. Then w44. What is w44? You can check here. W44 is 1. So minus 2 get multiplied with 1. It is minus 2. Now k is equal to 3. Last value. x3 of 3 is equal to x of 3 w4 2 into 3. K is 3. So 2 into 3 is 6. So it becomes x3 of x of 3 is minus 2 minus 2j and x4 3 into 2 is 6. x4 6 is minus 1. So this value x of 3 get multiplied with minus 1 and it becomes 2 plus 2j. So this is our x of 3, 10, 2 minus 2j minus 2, 2 plus 2j. So this is x3k. Now one more DFT we need to find, that is x4n. What is x4n? 4646. This x4n DFT also we have to find by using the result of first, that is x of k, which we have calculated by matrix method. So here also we need to check the relation between x of n and x4n because we are using the result of this one to find the DFT of x4n. X of n is this one. So when we want to find the relation, if the sample values are same, only if there is any shift or shuffled values, same values you are getting in x4n, then there is a shift operation, either delay or advance. But here you can check here, the sample values are 1, 2, 3, 4 in x of n, and in x4n it is 4646. We want to use the result of this one, but sample values are not same. So there might be another operation. We have the result of x3n also. Just we have calculated. Now check whether this x4n, because we have the result of x of n and x3n. So we can use it to find the x4n. So for that, we can check whether x4n is related to the x of n, x3n, any combination. Here we can check addition of samples of x of n and x3n. 1 plus 4, 1 plus 3 is 4. 2 plus 4 is 6. 3 plus 1 is 4. 4 plus 2 is 6. So this x4n is nothing but addition of x of n and x3n. So here we can use linearity property. What is linearity property? If in a time domain two sequences get added and if we know the DFT of this one and DFT of this one, then DFT of x4 of n is also the addition of individual DFTs. That is DFT of x of n and DFT of x3n. So previously we have calculated the DFT of x of n by matrix method and DFT of x3n by applying circular time shifting property. Here, to find the DFT of x4n, as x4n is the combination or addition of x of n and x3n, here we are using linearity property, and it tells that when time domain two signal get added, in frequency domain also that individual DFT get added to get the DFT of added sequence x4n. So x4k DFT of x of n is x of k plus x3 of k. X of k we have calculated by a matrix method. Then x3k we have calculated by applying time shifting property. And now here we can add it. 10 plus 10 is 20. Minus 2 plus 2j, and here 2 minus 2j. This minus 2 plus 2 get cancelled, plus 2j minus 2j get cancelled. Second sample is 0. Then minus 2 plus minus 2, minus 4. And this minus 2 plus 2 get cancelled, minus 2j plus 2j get cancelled. That's why 4 sample is 0. So the DFT of x4n is 20, 0, minus 4, 0. So in this example, we have used two property. In the first, we have calculated x of n by direct matrix method. Using the result of this x of n, we are finding x3n, which is just shifted version of x of n. That's why we have applied time shifting property. Then x4n, this is addition of x of n and x3n. That's why we have used linearity property, and we have added the DFTs of x of k and x3k to get the x4k. So this is the example which will be very useful during your exam. Thank you.